Hello friends, welcome to my channel. My name is Abhishek and in today's video we'll discuss what is Chinese Remainder Theorem. If you are new to this channel, I would like to tell guys, this is our cryptography series going on. Approximately 25 videos have already been uploaded. You can check out, I'll give the link in the description. Now let's start this video. Chinese Remainder Theorem states that there always exists an x is an integer value that satisfies the given congruence. Suppose for an example, we have a number, num and remainder. Suppose let us have two arrays and num is having some integer values and remainder is also having the remainder value. So if we divide x by that number, we'll get some remainder, right? So that's why x will be congruent to remainder, that particular remainder value, modulus of that number value. So we'll have these congruent values, congruent expressions, a lot of congruent expressions. And the thing is that all these values, that is num0, num1, all these numbers should be co-prime to each other. That is, all the numbers should have the HCF as 1. GCD of num1, num2 should be equal to 1 and so on. We'll see that. Let us see the example. It will be more clear to you. Suppose for an example, x is congruent to 1 modulus 5 and x is also congruent to 3 modulus 5. So if we have to apply the Chinese remainder theorem here, so what we are supposed to do is that 5 and 7 should have GCD 1. That is, 5 and 7 should be co-prime. If we have three expressions like we have in this case, then 3, 4 and 5, they all should be co-prime to each other. That is, GCD of 3, 4, 4, 5 and 5, 3, it should be equivalent to 1. Only then we can find the value of x, else we cannot find the value of x. Okay, so this is a simple rule. So basically Chinese remainder theorem is used to find the value of x. When we divide a number by some number, particular number, we get some remainder, right? So if we divide that particular same number with some other value, then we'll get some other remainder. So that's why in these cases we use this Chinese remainder theorem. It can also be used to solve what mathematical problems. Like for an example, if we have n number of chocolates and we divide those chocolates into a group of 5 students, then we get the remainder what? 3 as the remainder. And if we divide those same number of n chocolates to approximately, let's say 10 students, then the remainder is 1. So we are supposed to find what? The n number of chocolates. So in these cases we can use this Chinese remainder theorem to get these values. So this is the same question I have explained here. I have just taken n number of books and I have told you about the chocolate example. So guys, now let us understand what is Chinese remainder theorem all about. Let's see the algorithm first. If you are asked that please explain the Chinese remainder theorem, then you are supposed to follow these steps. So guys, in this Chinese remainder theorem, suppose for an example, for the sake of understanding, I have taken here three conditions. So x is congruent to a1 modulus m1. Similarly, x is congruent to a2 mod m2 and x is congruent to a3 mod m3. So what we are supposed to do is we have to find the value of x. So how will we get the value of x? Now let us discuss that. So first of all, the main condition is if we have to find this value of x, then the condition is that GCD of m1, m2 and m3, they all should be co-prime to each other. Then only we can find the value of x, else we cannot go ahead. So that's why GCD of m1, m2, m2, m3 and m3, m1 should be equal to 1. That is, they all should be co-prime. The first condition is this. Then to find this value of small x, there is a simple formula like x equals m1 x1 a1 plus m2 x2 a2 plus m3 x3 a3 and so on. If you have n number of expression, then you will go up till mn xn an, and then when you will add all these value, then you will find the modulus value with m. This is mod m. Okay, m is capital M here. Let me zoom it out a little bit. You can see now. Yeah. So how will we find these value m, capital M1, capital M2, x1? Now we'll see that. So guys, initially in this formula, what we are having is we have the values of a1, a2 and a3 respectively. For this example I'm talking about, so we have the values a1, a2, a3. This will be given in the question, okay? And we'll have to find the value of capital M, m1, m2, m3 and then x1, x2 and x3. So now let us see how will we find the value of capital M. So friends, the value of capital M will be what? m1 into m2 into m3 up till n. If you are n number of expression, then you will have to multiply all the numbers by which we are dividing here. Okay, so simply what we are supposed to do is we'll have to multiply 5 and 10 if we have only two values. Then capital M will be m1 into m2, that is 5 into 10, that will be 50. Okay, so capital M we will find it using this formula. Then simply we have got this value also, capital M. Now we are supposed to find what? m1, m2, m3 and x1, x2, x3. So how will we find the value of m1 or mi? We can say mi, I is denoting 1, 2, 3 and so on. So to find the value of mi, you will have to divide the value of capital M, which we have calculated here just now. We'll have to divide it by what? Small mi. For an example, let us say if I have to calculate the value of capital M1, then what I'll do is I'll divide the value of capital M, which I have calculated over here, m1 into m2 into m3. I'll divide it by m1 simply. So m was m1 into m2 into m3. I'm talking about specifically for this example, okay, for the sake of understanding. It can be n expressions also. So what you will do is you'll multiply m1, m2, m3 up till mn, okay. So for these three expressions, you will get what m1 into m2 into m3 divided by, if I'm finding the value of m1, then I'll divide by small m1. So I'll divide it by small m1, and when I'll solve it further, so m1 will get cancelled. So guys, you will get what? m2 into m3. So that's why your value of capital M1 will be equal to small m2 into small m3. And similarly friends, your value of m2 capital M2 will be equal to what? m1 m3, and the value of m3 will be equivalent to what? m1 m2. So why is it so friends that we are getting the value of m2 as m1 m3? It is so because when we'll divide capital M by small m2, what we'll get is capital M, value of capital M is what? m1 m2 m2 into m3, and simply when we'll divide it by m2 will get cancelled, and you will get is what? m1 m3. So that's why you will get the value of capital M2 as small m1 into small m3. Similarly, you will get the value of capital M3 as m1 into m2. So this is how you will calculate the value of capital M1 or m2 or m3. This is the formula. Okay. And friends, now when we are supposed to calculate the value of xi, that is x1, x2 and x3 in our formula, so we have got the values of m1, m2 and m3 also. So now we are just left with what? x1, x2 and x3, capital x1 and x2 and x3. So guys, now let us discuss how will we calculate this value of xi or x1, x2, x3 we can say. So what is this xi? This is nothing but just the multiplicative inverse of your mi value. So friends, if we are calculating the value of x1, so it is a multiplicative inverse of what? m1, capital M1. So when we'll multiply m1 into x1, it should be congruent to what? 1 modulus of small m1. When I am finding x1, I'll use here capital M1 and small m1. This is the point to be noted. Now friends, now let me explain you with the help of one example. Okay, so here's a numerical friends. Simply in the question we will be given that find the value of x, and you will be given these three expressions as x is congruent to 1 modulus 5, x is congruent to 1 modulus 7, and similarly x is congruent to what? 3 mod 11. Now one thing to note here is friends that the value of a1, a2, a3, they can be same also. Like in this case the value of a1 and a2 are same, but the values of these m1, m2, m3, this must be different. Why is it so? Because these values should have a GCD 1. Okay, these all numbers should be co-prime to one another. So we had the formula x is congruent to ai mod my. That's why the value of a1, a2, a3 will be what? These values 1, 1 and 3 respectively. 1, 1, 3 I have written here simply. And the value of mi, that is m1, m2, m3 will be what? 5, 7 and 11 respectively. So this is what I have written over here. So when we'll start, we are supposed to tell what? Since all these three numbers 5, 7 and 11 are relatively prime, that is co-prime numbers who have their GCD as 1. So that's why we can proceed further. We can say we can find the value of x. You should also write this GCD of 5, 7, 7, 11 and 11, 5 is equivalent to 1. So after that we'll move ahead. Simply we'll find the value of what? Capital M. Why we are finding the value of capital M? Because to calculate the value of small x, we are supposed to find out capital M, capital X, and we have the value of a1 already. Okay, so we'll calculate the value of capital M. How? m1 into m2 into m3, simply by using that formula. So that's why m1 into m2 into m3 will multiply all these three numbers, will get is what? 385. Okay, so 5 into 7 into 11 is what? 385. So this is the value of capital M. And now we'll find the values of m1, m2 and m3 respectively. We have learned just now guys that the value of mi, that is any mi, that is m1, m2 or m3, how will we calculate that? We'll do capital M divided by small m1. So what will be the value of m1? That will be m2 into m3, that is 7 into 11. m2 into m3, the value is written over here. Can you see that? Yes, 7 into 11, that is 77. And similarly friends, the value of capital M2 will be m1, m3, that is 5 into 11, that is 55. And similarly m3 will be equal to what? m1, m2, that is 5 into 7, that is 35. Okay, so I have written the values over here so that it can be more clear. m1 is 77, m2 is 55 and m3 is 35. So guys, now we have calculated the value of capital M also and all the values of mi also, that is m1, m2, m3. Now we'll simply find the value of xi, that is we will find the multiplicative inverses of m1 and m2 and m3. Now friends, we'll simply find the value of xi, that is nothing but the multiplicative inverse of x1, x2 and x3. Okay, so friends, to calculate the value of xi, we'll simply do what? mi xi is congruent to 1 modulus of m1. This is the basic formula. So for x1 we are calculating, that's why I'm using capital M1 into x1 is congruent to 1 mod m1. When I'll substitute all these values, so m1 we have calculated what? 77. So 77 into x1 we are supposed to find out. Modulus of m1 was 5, should be equal to 1. Okay, why is it so? Because if we have the congruent values like this, so friends, we can represent it in this way also. m1 x1 modulus of m1 is equivalent to 1. Okay, so congruent value can be extended like this. Okay, we can represent it in this form also. So friends, now m1 value was 77, that's why 77 into x1 modulus of 5 should be equal to 1. We are supposed to find out a number x1 such that the conditions get fulfilled. So simply what we'll do is, when you will divide 77 by 5 friends, to make the calculations easier, I'm telling you this thing. Else you can also substitute the values of x1 and multiply it with 77, and when the remainder comes 1, you can take that value. So guys, to make the calculations easier, what you can do is simply divide 77 by 5. You will get what? The remainder as 2, okay? Because 5 into 15 is 75 and the remainder is 2. So we can write the value of remainder here and multiply it with this number 2 into x1, and when we'll find the modulus value of this, it will be equivalent to 1 only. Okay, so this is a property of modulus operation. I'll make a separate video for that, but for the time being friends, this is the case. So simply when you will divide 77 by 5, you will get a remainder 2. When you will multiply this number, that is x1, with 2, and when you will divide it by 5, you will get some remainder, and if that remainder is 1, then that will be the value of x1. So when you will keep the value of x1 as 3, you will get the remainder as 1, because 2 3s are 6, and that's why when you divide it by 5, you will get the remainder as 1. Okay, so this was the case. The value of x1 is 3. Similarly, we'll find the value of m2 and m3. So we'll use this equation, capital M2 into x2 is congruent to what? 1 modulus m2. So again we can represent it in this form, 55, that is m2 is 55, we have calculated earlier, 55 into x2, capital X2, modulus of m2, that is 7, is equal to 1. So what we are supposed to do is friends, we are supposed to calculate the value of x, and when we will divide friends 55 by 7, we'll get the remainder as 6, because 7 times 7 is 49, and simply when you will subtract 55 by 49, you will get the remainder as 6. So we are supposed to find out a number now x2 such that 6 into x2, and when we'll divide that number by 7, you will get a remainder value as 1. Okay, so 6 6 are 36, and simply when you will divide it by 7, you will get the value as 1. Okay, so this is the hit and trial technique you can use. So guys, you will become a pro when you will solve these questions. So for the time being, you might be feeling a little bit uncomfortable, but it will be easy. Okay friends, so what we are supposed to do is we have to find a value such that 6 into x2, that is this value, this will be a particular number now, like x2 is 6, so 6 6 are 36. So we have to find out a number that is 6 into x2 whose value will be one value more than the multiple of 7, least multiple of 7 actually I should say. Okay, so that's why 6 into 6 is 36, and 36 divided by 7 will give us the remainder as 1. So that's why x2 value will become what? 6. And in the similar manner friends, we are calculating the value of x3. m3 into x3 is congruent to 1 modulus of m3. We are substituting the values. m3 was 35, x3 simply we have to find out congruent to 1 mod 11. So simply friends, when we'll divide 35 by 11, we'll get the remainder as 2. That's why 2 into x3 is congruent to 1 modulus of 11, or we can say that friends, 2 into x3 modulus of 11 is equivalent to what? 1. So we have to find the value of x3. Now when you substitute the value of x3 as 1 2 3 4 and so on, you will see that the value x3 equals 6 satisfies this equation. So friends, 2 into 6 is 12, and when we will divide 12 by 11, you will get the remainder as 1. So that's why the value of x3 is 6. So till now we have calculated all the values required. So guys, the value of a1, a2, a3 were given in the question. m1, m2, m3 was also given in the question. We have already calculated the value of capital M1, capital M2 and capital M3 respectively, and capital M also we have calculated. And now we also have the values of capital X1, X2 and X3. So all the values I have written over here. So friends, we have calculated all the values. Now simply we'll put it in this formula, capital X equal to m1 x1 a1 plus m2 x2 a2 and so on. So now let's do that. So this is the formula friends, m1 x1 a1 plus m2 x2 a2 plus m3 x3 a3, and whole modulus m value we have to find out, and that will be the value of x. So simply we'll substitute the values m1 x1 a1 from all these value over here. When we'll substitute this value, we'll get what? We'll get the value of x as 36. Okay, so after calculation friends, it might happen that you don't have calculator. So after calculating all these value, after addition of all these values, suppose you will get the answer as 1191 mod 385. If you don't have calculator, how can you solve? I'll teach you a technique. You just subtract that number 385 from 1191 till the time you get a number smaller than 385. So simply 1191 minus 385 is 806, and then again 806 minus 385 will be 421, and simply 421 minus 385, this will give us 36, which is a value less than this particular number 385. So that's why this will be our answer. Okay. And if you want to verify our answer, now you can check. When we'll divide 36 by 5, 5 7s are 35, so that's why you will get the remainder as 1. Yes, the condition is met, it is fulfilled. 36 mod 7, when we'll divide 36 by 7, you will also get the remainder as 1, because 7 times 5 is 35, and simply you will get the remainder as 1. Okay, so this condition is also fulfilled. And in the third condition friends, when you will divide 36 by 11, you will get the modulus as 3, because 11 times 3 is 33, and simply when you will subtract 33 from 36, you will get the remainder as 3. So all these three conditions are met. In this way you can verify your answer. So friends, you can take this screenshot if you want, and this is the formula part. So friends, if you liked my video, please rate, recommend and review, and do subscribe to my YouTube channel, because I upload lots and lots of educational videos. So friends, you can follow me on Instagram, You can search Abhishek DIT, and I have made a WhatsApp group also for all my audience. If you want to join that group, you will get the link in the description. So take care, goodbye.